On this part of math, we are going to talk about logarithmic functions as introductions. Then on the questions, we're going to solve the questions that are related. Okay, logarithmic functions. Just as introduction here, look, if I tell you now 10 power 2, you know the answer is what? Is 100. So 10 power 2, the answer is 100. Okay, this one now I can reshape it. I can rewrite it in another way as log. How? I can write it like log. Okay, and I write the base. What is the base here? This is the base. The base is 10. So this base now I write it here, which is what? 10. Good. Then I write here the power. What is the power here? The power is 2, so you write it here. And in this place, you write the result. What is the result here? 100, you write it here. So when you find log, that means you have base, and you have here power, and you have here result. Keep that in mind. So this is the base, and this is the power, and this is the what? The result. Good. So that means whenever you find difficulty in logarithmic way, it change it to be exponential way. Change it to be this way. So this one now is logarithmic form, and this one is what? Exponential form. So it changed it from, if you are able to change from this form to another form, questions that you're gonna solve them, you're gonna find them what? Easy. Just make sure how you change. Okay, look here now. If I tell you now 8 power 2 equals 64, it changed it into logarithmic way. You're gonna change it to log. What is the base here? The base here is 8, so you write it here. And what's the power? The power is 2, so you write it after the equal. Good. And what is the result? The result is 64, you write it what? Here. So this is now how it becomes. Okay, now if I tell you log, and I give you the base is 5, and here I give you 25, and here's what? 2. And I tell you now, I change it into exponential form. To change it to exponential form, you write the base here 5. This is the 5, and then its power. What is the power? 2. Then you write the result. The result here is what? Is 25. So look here now. Make sure you understand each number and its place and what does it represent. So here it represents the base, and here it represents the power, and here it represents what? The result. So keep that in mind. Okay, now if I delete one of the places, if I delete you here the number, and I write to you instead of it, and I write you what? I write you B, and I ask you what is B. That means now, when I tell you what is B, that means, remember, what am I asking for? Am I asking about the base or the power or the result? Keep that in mind. So that means if B is here, if the variable is here, that means I'm asking about the power. So that means you're going to read it like 5 power what gives me 25. Then you can understand that B is what? Is 2. Okay, what about if not the B, if I erase you the 25? Then the B is there. The B is there as what? As 2. Then if I write you here now, the variable is here, and that means in this case I'm asking you about what is the result. So you're gonna write it 5 power 2 gives me what? So you're gonna understand what is here. So try to understand exactly the places and what do each place mean. So you have base, you have power, and you have result. So if X is there, X can be in the base. So the variable, I can ask you what is the base, or what is the power, or what is the result. So you need to understand where is it exactly. So look here, if I give you example, log 327 equals what? So in this case, what am I asking for? As long as this is the base and it is given, and this is the power and it's not given, and this is the result and it is given, right? So that means it is 3 power what gives me 27. Look how you write it, 3 power what? Like this way, you move counterclockwise. 3 power what gives me 27. You can understand that it is what? 3, because 3 power 3 is 27. So you write the result here is what? The result is, you write it as what? As 3. Okay, what about if I write you now log, I write you here X, then I give you here 8, and I give you here 3. What now I'm asking for? I'm asking for now what? The base. So the base now is a number power 3, it will give me 8. What could be that number? You can think of it mentally, by the way. If you understand these ideas, where the place and what does that place mean, you're gonna solve it easily. So it's a base. Okay, what number that when you make it power 3, it will give me 8? You understand that it is 2, because 2 power 3, it will give me 8. So that means the x now is in the place of the 2. So the x is what? Is 2. I hope now you understand mainly logarithmic, how it is as another form of what? Of exponential, of exponents. Good. Now, if we write it as its parent function, it is y. Look, it is y equals b power x. This is when it is exponential, if you remember. This is what? Exponential. Okay, its inverse function now, it's gonna be y equals log base, whatever is the base for x. So this one now is what? Is the function. And the y, it represents the power. And this is the base, and this is the results. So b power y will give me what? Will give me x. Will give me x. Okay, how is its graph as a parent function? This is its graph. This is y and x, and it goes from the negative side of the y, then it goes into what? This direction. And it's asymptote. That means the line that it doesn't cross is this one, which is x equals what? X equals 0, which is the y-axis. This is as a parent function. That means without any transformation. But you can transform it. You can move this graph up or down or left or right, as we studied in parent functions transformation. But if it is parent function here, as you see, y equals log base b for x, this is how its graph, and it will move here from the point that is what? X equals 1. Good. Here now, we need to understand more what is its domain and range, and keep that in mind. Look, as you see the range now, but if you remember when we studied exponential functions, well, its domain was all real numbers, and its range was y greater than 0. And by the way, logarithmic function, it's exactly the inverse function of what? Of exponential function. So if exponential function, if you remember, it was y equals b power x, right? And as inverse function, if you remember, to find inverse function, just to change x to be y and y to be x, right? So that means it's gonna be x equals what? B power y, right? So that means as a logarithmic, then if you change it as log, it's gonna be this way that is written here. It's gonna be y equals log b and x for x. So now the logarithm, this one here, which is exponential, its domain was all real numbers, and its range was y greater than 0. Okay, now the inverse function will be the opposite. So the domain of this one will be the range here, and the range will be the domain. Then in this case here, just what do you need in short to understand is, if we are talking about logarithmic function, we understand its form and we understand its graph, and now we understand just its domain and range. From the graph, you're gonna see that its range is all real numbers. Its range is all real numbers. But its domain now, that means which is the values of x, it is the values when x is greater than 0. So that means the domain will be positive numbers that are greater than 0. This is the domain of logarithmic functions. The domain will be the controller of all our solutions. When we solve logarithmic functions, the domain will be the controller that controls how we find the values of x. For example, if you solve one question, then you find two values of x, x is negative and x is positive, you're going to choose the positive one because it is included in the domain, and you're going to reject the negative because it's not included in the domain. Okay, we understand now how we change exponents into logarithmic form. We understand the parent function and its graph. Now the third and last point here for this introduction is the properties of logarithmic. Okay, the properties, if I have log, and here 10. As you see, power 2 is the answer is 100, right? Look, and it can be log 3 power 4. As we know, it gives us what? 81. 3 power 4, it will give us what? 81. Here I did 3 power 4, it gives me what? 81. Good. Here, when the base is 10, in some cases, no need to write it. That means if I write it like log 100 equals 2, and I'm not writing here a base, so whenever you see it is written log without a base, so that means you need to know that the base is what? The base is 10. Okay, if I ask you now, what is log 10? Will you be able to solve it now? Log 10 equals what? Look, you need to remember now what I gave you. Did I give you the base? Did I give you the power? Or what I'm asking for? I'm asking about the power. And since the base is not written, that means the base is already what? 10. So now 10 power what gives me 10? It'll be 10 power 1. So that means log 10, it equals what? 1. Good. If I tell you now log 1 equals what? Log 1. Get log 1, you're gonna see that the base is what? Is 10, but it's not written. So you deal with it right there. 10 power what? It give me 1. 10 power what? 10 power 0. Because any number power 0, the result will be 1. So that means log 1 equals what? Equals 0. And I hope that is what? That is clear. Okay, related to the properties now. If I have log x times y, log multiplication of two numbers, you can split them into log the first one x plus log what? The y. And that means now as math you can move left, right, or right to left. So that means if you have the left side, you can find it the right side this way. Or if you have the right side, you can change it to the left side there. Get another one. If I have log x over y as division, in this case you write it log x minus log what? Log y. So that means if it is division, that means subtraction. If it is division, then subtraction. If it is multiplication, then what? Then addition. Okay, if I have log the base, whatever is the base here, and I have here the base power 3, so that means the result will be the 3 itself. How? For example, now I give you here log 10, and here I get you 10 power 3. What will be the result? Look, it's gonna be 10 power what? Gives me 10 power 3. 10 power what? Gives me 10 power 3. Of course, it's 3. So that means it's directly the 3, as long as here the number and the number here equal. Like if you cancel them and you write the number that is up directly. Okay, same thing if I have b power log base, which is b, for any number like here x, the result will be what? X directly, like the same if you cancel what? These ones. Just these properties, you understand them, then we're going to apply them with the questions. So you're going to apply many examples. If I have here now more, if I have log 3 power 8, you can write it like 8 log 3. Log what? 3. So for example, now if I tell you now log 10 power 3, you can write it like 3 log what? Log 10. And what is log 10 as we studied? Log 10 is 1, right? Because it's here, it means 10 power what gives me 10 is 1. So that means this one represents 1, so the answer will be 3. As long as 10 here, it can be cancelled, or you take the power to be the coefficient. I hope that is clear. You understand just these properties. And again, okay, if I tell you now log 3 for x plus 2 equals a log 3 for 5. As long as here you have equal and log 3 and log 3 is there on both sides, that means this equals this one. So that means x plus 2, just you write equals what? 5. Then you send the, so that means x equals what? X equals 3. As long as the base in both cases is the same. And I hope that is clear. So you understand these properties, and you're gonna apply them in the questions. So you can solve them in the questions. If you have a problem, you can watch the videos related to the questions. Thank you so much. See you in other videos.